Okay, so if you want to scan QR code, you can scan. Yeah, hopefully you can see the my screen. Okay, this is the notes, my notes. So we'll start with some question from here. Okay. I have dealt some question in the other class, and I will later also attach uh, notes or link for the recording also. Okay, so I will start with number one. Okay, if you don't mind, okay, I'll start with number one, okay. And later start to maybe number five here, okay. And then maybe number six. Okay, so let's start number one first. Okay, let me put the sure. Okay, okay, start with this. Okay, okay, you can see this question. Okay, so find the line of the curve. Okay, so I will give you a couple minutes to try first. Okay, whether you still remember how to do it. Okay, let me just write some basic review on the arc line. So arc line, usually you write S or L is equal. Let's say this is A to B. Okay. So basically, in every arc line we need to find the first derivative. Okay, the first derivative. That's the first step. The first step. So we have y equal okay. This is our curve. Okay, our curve. We have integration from e to the x, from e to x of square root of ln t squared minus one. Okay. Now, if we want to make it or to find the first derivative, this is we are going to have the fundamental theorem of calculus, right? Which is we can take this take the x into inside t. So this will be ln x and then square. Okay. Okay, so far it's okay, right? And then we need to take square, right? So we are going to square this, square this. So we will have, okay. Then we are going to have L. We are going to evaluate x is from e to e squared, okay? So we are going to take it from e to e squared. This is 1 plus this ln x, okay? Ln x squared minus 1, and then the x. And you see that this 1 is going to be cancelled, and our L will be ln x squared, square root, the square root will be removed, and this will be ln x dx. Okay, if you remember how to solve the ln x, the integrations, we can use the integration by parts. So we can have uh, 1 over x here and x here, right? And we can cross multiply here. So we will have x ln x, and then plug in e and e squared minus the x from e to e squared, and we will have e squared ln e squared minus e ln e minus this is uh, going to be x, right? So we can write minus e squared minus e like that. So carefully evaluate this. It's going to be 2 e squared minus e. Ln e is 1. Okay, so let me write here. Ln e is equal 1. Okay. And this will be cancelled, and you will get the result is e with power of 2. Okay. The answer is C. Okay. Okay. So far, this is, I think, uh, quite simple. Okay. The first thing, as you understand how to put in the arcline formula, I think all the process is easy. Okay, next is number 5. Okay, that's number 5. So read the question first and try and maybe observe and check your answer. Okay, let me clarify. Okay, this means that this is f inverse, okay, f inverse, and this means the first derivative. So this means this at 0 is equal. That's the questions. Okay, this question seems a little bit misunderstood if you are not uh, carefully looking at the equation. Okay, so first let me write the functions. Okay, these functions I can write as, right? Okay, why I need to write or to switch the endpoint. Look, my endpoints now is changing because this is the default form for fundamental theorem of calculus if you want to use that. Okay. Okay. Now the questions is asking the f inverse, right? The f inverse. So if we take y as our functions of x, then the inverse is this, right? Let me just clarify and confirm to remind you how to derive this. Okay, if we derive this, then this is f inverse prime. This means the derivative of f inverse of y. Y is f of x. Okay, I hope you don't mind. I'm writing like this, and then chain rule of y. A chain rule of the f inverse y is we need to multiply with the y prime or the f prime x, right? Chain rule. Chain rule. Okay, and then this equal 1. So this is one component here, one component. So f inverse is 1 over f prime x. Okay, I hope you get the idea on the f inverse. Okay, if you have. Now we need to find this f inverse, right? To plug in into this equation. So from here, what we are going to do is we are going to use the fundamental theorem of calculus to derive this. Okay, so to find the f prime x. So we are going to plug in x cubed to t. Okay. So minus, okay, let me write minus. Write the square root to x cubed, like that, plus 14. This is, we need to also multiply with the 3x squared, the chain rule. Okay. Okay. Now, by looking at the functions itself, okay, by looking at the function itself, and looking at the idea of the questions, the question is asking the f inverse prime at 0. Okay, so which means if we have this, okay, have this, we are basically asking this, right? Let's say this is x. So what we are going to find is what is x? Oh, sorry, y. This is 0. So we need to find x. When we plug in x, the result is 0. So we are going to see here, we need to make this function 0. So what we are going to do is making this x equal 1. Okay? So that means when we have f at x equal 1, this will be 0. And when we have f inverse 0, this will be 1. Okay. Okay. Now the questions will be answered through this. So f inverse prime f of x. This will be f inverse is negative the whole thing here. Okay. So we will have negative okay. Right? So to make it 0, we need to have x equal 1, right? So f inverse prime f1. This will be equal 16 and 3. Then this will be 1 over negative 1 over 12. This will be d. Okay. Hopefully can help you. Okay, maybe any questions if you have. Okay. Now we can continue. Okay. We can continue. Let me go back to look for the questions. That is number 5. Uh, let's try number 6. Number 6. Okay, let's start at number 6. I'm giving you maybe 3-4 minutes to check. Okay. Okay, this question, the integral. Uh, if you look at the integral, there are several ways. If you look at this, the first one, if you are just taking the x factors out like this, do some partial fraction, but you still have this 7, and I think 7 is too much for partial fractions. So for example, if you want to make it into partial fractions, this is x7, right? So we'll have bx6, right, plus cx5, etc. I think not that ideal way doing that. So instead of do some the partial fractions, we can have, okay, whenever you see this form, okay, take out the highest degree of factors. Okay, in our case, is the x with power of 8, right? Take it out, which means we are going to have x8 is 1 minus, this will be x with power of -7, right? Okay. And now we are going to put the x with power of 8 on the top. Okay. Now it seems that we have a negative power. A negative power. Remember that when you derive, your power should reduce, right? So if your power is x squared, it become x minus 1, right? So if your power is -7, if you derive, it will be -8, and it will be perfectly fit for our situation here. So if we substitute, u is equal, then our du will be this. And it will be perfectly fit and can for canceling the x with power of -8. Right? So we will have this will be 1 over u du. Okay. Oh, sorry. It's not negative because it's already negative. So no negative here. So this will be 1 over 7. 1 over u is ln, right? Ln u. U is 1 minus x with power -7 is 1 over, let's see. We can rewrite this formula became x, okay, plus c. Now, if you look at the questions, it seems that we cannot find the suitable one, right? So we need to convert this, try to rewrite the form. And this I can put into the front. So we will have 1 over 7 ln. This will be minus ln x plus c. So this will be the answer. This. So yeah, this is a little bit tricky. So whenever you find this and you feel happy, you need to also check the options. If you cannot find, maybe you need to change your answer, change your form of the answers. Okay. So that's number 6. Okay. Okay, if you have any questions, you can feel free to write on the chat box. Okay, if you feel you need to have some review. But my plan today is just discussing this last year final exam. Okay, I think I can continue. So number 6, I will also share my notes after the class. Okay. Okay. Number 7, I think I have explained in the class, right? So I think we can go to number 8. Okay, which following statements are true? This will be having a multiple correct answer. Okay, multiple correct answer. So it can be more than one. So try first and we can discuss. Okay, I think we can check our answer. Okay, we can check the first one. Let me just read the first one. The arc lengths of the curves, okay, y equal f of x, and y equal f of x plus c for interval a to b are equal. So we will have two curves. This is the first curve. This is the second curve. Okay. Now, if we have a curve, let's say this is the f of x. What does the f of x plus c means? Okay. So it means that it's actually the same f of x, right? But different positions. So let's say we have let's say here, maybe around here. So it's plus c on y-axis, right? Okay. So it's actually the same curve, which means that's true that it has both have the same length. Okay, so it's true. So A is true. But we need to check other answer as well. We need to check B. B is if function is continuous, it's a decreasing functions from 1 to infinite, then the limit is equal 0. Then the integrations is convergent. Okay, is it true or not? So let me just write what we have. We have the limit as x approaching infinity of f of x is 0. We say that the integrations is convergence. And f continue and decreasing from 1 to infinity. Okay. Now, functions that decreasing. It seems that it's correct, but we can check. We can check. If it's saying converge or diverge, we need to show some obvious example. Okay. For example, the obvious example that we probably can imagine is the 1 over x. Okay. 1 over x is having decreasing functions, right? From 1 to infinite. Okay. It's decreasing. F is decreasing. And if we are going to have uh, the area under the curve, we will have, or in our case is, it should be from 1. Let me just write A for area. So this will be 1 over x dx, which is diverge, right? So the statement is not applicable to all statement, to all case. So we can say that this will be false statement. Okay. Okay, that's the C. Okay, C. C say that the line of the curve is has this formula. So curve is y equal x cubed from 0 to 1. Okay. So the length will be from 0, 1. And y prime is 3x squared. So we will have 1 plus 3x squared dx. Or we will have 1 plus 9x with power of 4 dx. So it's 9x with power of 4. This is having x with power of 6, so it's false statement. Okay, the D. D is, okay, this statement. If f, okay, let me write here. If f less than g, then this is, if this is diverge, then this diverge, sorry. Okay, this is the comparison theorem. Okay, so if you remember, you can check your notes if you want, that when we have f is less than g and this g is diverge, then f is also diverge. Okay. So this is true based on comparison theorem. So we know that the answer is A and D. So the true statement is A and D. Okay. All right. Okay, we can check other questions. I think nine and nine I already uh, prepare. I will later um, attach the notes and links. Number 10 also we have in the class last time. Okay. And number 11 also already done. So we can go to number 12 and 13 probably. Oh, number 12 also okay. Also, we can, okay, I think we can go to number 13. Yeah, let's just go to number 13. Okay. Okay, let's try this one. You can try first. Okay, I'll give you maybe 2 minutes to try, 2 to 3 minutes. Oh, I found okay. Oh, yes, yes. Sorry, sorry. Okay, okay. Let me go back to number 8. This should be this, right? Should be this. And this should be yeah, yeah, this should be greater equal. Okay. So if you're just looking at the ABCD, it's only A. It's only A, sorry. So this is, yeah, 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 true, true. This is actually fast, but uh, yes, yes, okay. Yeah, it should be greater if you want to be this if you want it to be true. Okay. So if you look just by this for statement, this is only A. Okay, sorry, sorry. Okay. Okay. Okay, thank you, Evander. Okay, back to number 13. Okay. Okay. Okay, if we look here, uh, what we can do first is find the intersections on these two curve, right? X cubed and X. So of course it's X equals 0 and X equal plus minus 1. So this will be 1 and this also negative 1, 0. Okay. So the first one is that. Okay, and it's rotated through y equal negative 1. Okay. So how do we deal with this? Okay. So we are going to have, okay, we are going to have, if I draw this rectangle here, this will be the dx. Okay. So at least we have two regions. Okay, the first one is, let's say here, let's say this is volume 1, this is the volume 2. Okay. Okay. Now to solve this, if we rotate with respect to y equal negative 1, if you rotate that region, then we will have the uh, we have two radius, right? This is the first radius, and this is the second one, right? So if we take the phi one, the volume one, we take pi from negative 1 to 0. Okay, this will be x cubed plus 1 squared, the length of this blue line, right? minus the let me maybe using different color, maybe a yellow, this line here, this second radius, the inner radius. Okay. So minus the inner radius is x plus 1 squared. Okay. All multiplied with the x. Okay, solve a little bit. Okay, solve a little bit. So this will be x power of 6 plus 2x, or let me write first and then we can simplify later. Plus 2x cubed plus 1 minus x squared plus 2x plus 2. Plus 1, sorry. And this will be cancelled. Okay. So we will have, let me just write. Okay, that and the x. Okay, we integrate. Half x4 minus 1 over 3 minus x squared from -1 to 0. Okay, v1 pi is 0. Okay, 0 minus 1, it's minus 1 is plus for even. This is also minus and minus. Okay. Okay, in the exam, whenever you find something like this, do not rush to take this and calculate. Don't do that. Okay, just leave it first. Leave first, and then try to evaluate the volume 2. Volume 2 will be uh, the whole here, the whole thing here. Let me just get to. Let me erase first. Maybe here, and second one is here. Okay, so that the first one is x. Okay, so x plus 1. Okay, let me write here. This is now is from 0 to 1. This is x plus 1 square minus the second one is the x cubed, the yellow one here, the yellow one. So x cubed plus 1. Okay, x cubed squared. So we are going to evaluate this. X squared plus 2x plus 1, x6 plus 2x cubed plus 1. This is minus. So we will have similar forms, but not equals, but similar. Okay. Okay, so pi, this will be becoming -1 over 7 x to the power of 7. Okay, now you see this seems similar, so we can compute the volume of the total. So pi negative 1 over 7, negative half plus 1 over 3 plus 1. This should be, we can compute first. This should be 1 over 7. Okay. So plus 1 over 7, half plus 1 over 3 plus 1. Oh, this should be, I think should be plus. Okay, should be plus. Should be plus or minus. Minus 1 minus 1 minus minus plus, right? Plus. Okay, this should be, let me check first. It should be plus. Oh, this should be minus x squared. Let me check first. Is it true? I think it's cancelled, right? This is negative 1 plus 2. I think this should be cancelled, right? Oh, this, okay, minus. Sorry. So this is correct. This is okay, minus. Okay, sorry. Should be okay. All right. Now pi is 2 minus 1. So it's pi. The answer is okay. So my suggestions is do not attempt to evaluate the whole thing here. Okay. Keep just as in the fraction. Okay. All right. We can go to the next question. Let me check the question first. Okay, we can have two more questions, I think, or three. Okay, try this one. Okay, the integral. Okay. The problem here is we have x squared and square root of cubic root of 1 minus x. Okay. Problem is we have the cubic root, but I think the cubic root is not really a problem, right? Well, if you want to um, solve it through some substitutions first, for example, this 1 minus x, and then you get this is 1 minus u, and you get x squared is 1 minus u squared. And from here you get the idea that du is equal negative dx. So dx is negative du. Well, it's not really helping, but we can do this as well. So integrations, x squared is 1 minus u squared. And this is u, and then 1 over 3 du, and then minus. So this is 1 and 0. But still, you need to solve through, I think, integration by parts. Okay? But if you think this models seems easier, and you can do it. You can do that as well. But let me just use the original one here. Okay. So x squared, and we have 1 minus x, the power of 1 over 3. And take this to differentiate, and this one for integrations. Okay. So differentiates, become 2x, become 2, become 0. And integrate this. So plus 1 should be 4 over 3. But we have the negative, so we have negative 3 over 4, 1 minus x, 4 over 3. Okay. This is a little bit complicated form, but still we can integrate this, right? And then again, plus 1. So it should be 7 over 3. Okay, let me just write 7 over 3. So we need to multiply with the negative, so it should be positive. This will be 9 over 28, 3 over 7, right? Okay, one more. We are going to have, okay, again, this is plus 1, so it should be 10 over 3, okay? And this should be a negative, thing negative. 3 over 10 is 27 over, okay, should be negative. Now we are going to have, let me just write here. Oh, I need to write maybe both here. Evaluate from 0 to 1. And if we evaluate 1, this will be 0. This will be 0. Okay. All will be 0, right? If we evaluate 0, this is 0, this is 0, and we have just this left. So we will have something 0 here minus this minus 54 over 280. So we'll have 54 to 80, or we can simplify, it becomes 1 over 5. Or no, it's 1 over 5? No, I just keep it 54 over 280. Okay, yeah, a little bit calculations, but I think still can be done. Okay. If you have any questions, you can write on the chat box. Okay. So that's number 14. Uh, you can use integration by parts to solve. Okay, let's, I think, number 15 and 16. Okay, we can have two more questions. I'm not sure if I already explained in class, but let's try one more time. Okay. Find the value of p to make the integral converges. Try maybe for a few minutes. Oh, sorry. Okay, so the key for the p test. Okay, this is usually we call p test. Okay, this is p test. Okay, so the key is to observe p. Okay, in here in the form of usually it will take form like this, and you need to notice there will be plus or minus sign. Okay, the key in the limit is if you have a limit, if you have one, let's say this is t and t is getting 0, this will be infinite, right? This will be infinite. Or if you have t and getting approach to infinite and you have 1 over t, this will be approaching 0. So from this basic knowledge of limit, then what you have here, okay, if you have the p minus 1 positive and p is greater than 1, and when we have the limit as the t approaching 0, okay, then we know that this will be a positive, right? This will be a positive. P minus 1 is positive. So as t is getting 0, the whole thing here also getting 0, which means the conclusions that 1 over that t it will be getting infinite. So we can conclude that this will be divergent. Okay. So that's the idea. And if p minus 1 is negative, okay, so as t is getting to 0 from the right, okay, so we will have t p minus 1 if this is negative, okay, this will be 1 over t, right? 1 over t. So if this is negative, we can write this as for p less than 1, we can say that this part is infinite because this is 1 over t. Okay, so for 1 over t p minus 1, this seems to be 1 over infinite in limit. Okay, so this will be resulting in 0. Okay, so that means that this will be convergent. So you need to be careful on the negative and positive signs to determine the limit. Okay? The reciprocal form, I mean. Okay, so that number 15. Okay, I hope you get the idea. And hopefully you can have more exercise on many types of questions regarding this. This is called the p-test, okay, the p-test. So we need to test the interval of p, and we need to find whether the interval we need to find it's whether we need to find the convergence or the divergent one. Okay. Okay. I think lastly, or maybe if we still have time, we can have one more questions aside from the final. All right. Uh, Number 16. This is the surface area. Okay, you can check the question first and try to solve it. Okay, now the question here, we have the curve. The curve is in a function of y. Okay, so okay, basic information for you. Okay, so if you have a surface area problem like this, you can have two different type of surface area, right? You can have, but the basic, okay, the basic of the surface area, say the s is 2 pi r, and let's say the s. The s is, this is the arc length, and this is the radius. So based on what we have in arc length can have dx and can have dy. Okay, and no matter what in the surface area, you can choose, okay, which radius you are going to take. Okay, for example, if I have this, or let's say we have the rotations about y-axis like this, we rotate through here. Okay, let's say this is the curve, then this will be our radius, right? Now we can have this as x, okay, or function of y. Depends. If you want to make this x, then we need to make the arc length in x. If you want to make the r is, let's say, function of y, we want to make the arc length in dy. It depends on how complicated our functions will be. If we look at the curves here, and it's already have y and negative y like this, my suggestion is just to keep that as a function of y. Okay, that's will be really helpful. Okay, well, if you want, you can change the y into x, and maybe you need to use some ln, okay, to convert. But I don't suggest that way. We can just do fine just using dy. Okay, so let me write here the x, or the function of y, is e with power of y plus e with power of negative y divided by 2 from 0 to ln 2. Okay. Okay, because we are going to use dy on the integrations, then we need to find dx over dy. Okay, now here we can write this in terms of this. Okay, so we integrate, oh, not integrate, we derive with respect to y. So half e with power of y still, and derivative of e with power of negative is become negative. Just that. Okay. And the in arc length, we need to square all of this. Then we are going to have the x over dy squared is equal 1 over 4. And we are going to have e with power of 2y. This is, so I can write this is cancelled. So minus 2 plus 1 over e 2y. Okay. Seems a little bit complex, but let's just keep this way. And let's say plus 1, okay, because in arc length we need to plus 1, right? So let's just calculate all things here. So this will be 1 over 4 e with power of 2y negative half plus 1 over 4 e 2y, like that. And then plus 1. 1 minus half is half, so we can write 1 over 4 plus half plus 1 over 4. Okay. We factorize 1 over 4 and we get this. Okay. Oh, sorry, this is e. Now this is 1 plus dx over dy squared. Okay. Next thing, in arc length, we need to have the square root, right? So we need to square this. Square root. So square root of 1 plus dx over dy squared. This will be half. And the inside, if you look it closely, this will be turns out to be, if we have e, this is squared, this is precisely the same thing, right? So this is actually this. Right? So when we square root, then we can write down that this is e with power of y plus e with power of negative y. Okay, now this is the arc length. The arc length. So the surface area will be 2 pi from 0 to ln2. That is for y, right? That's the more reason that we need to keep in y, okay, instead of changing to x. If you change to x, then you need also to change the endpoints, right? Okay. So this will be start with the curve, the radius itself, or in our case is our x, but we are going to use the function of y. Then we are going to write down here is e, okay, multiply with the arc length, we have this, okay. So we are going to have the same equations, and don't forget dy, okay. So let's solve a little bit. So this will be pi over 2 going outside 4, and then we are going to have e y plus e negative y squared dy. Okay, let's solve this. Okay, let's solve one by one. This will turns out to be e2y divided by 2 integration plus 2y minus from 0 to ln2. Okay, let's plug in ln2. ln2 become ln4. This ln4. This become 1 over 4 because of negative. And this will be minus, this is half minus half, okay, because of the e with power of 0. This will be cancelled, right? ln4 is 2 ln2, so 2. 4 divided by 2 is 2 plus 2 ln2. 1 over 4, 1 over 8. This will be cancelled. So this will be, yeah, I think up until here you can finish. Okay. Okay. Okay, I think I will just, I think we just stop here. Uh, if you have any questions, you can write on the chat box. So, see you on the final exam, okay? Thursday. I will share one more time later the place, the time to remind you to come to the class. Our place or our classroom will be on the IB buildings, sixth floor. Okay. There will be two class. Oh, not IB. That's the other one. I think fourth floor. Let me check first whether it's true. Yeah. Okay. Let me just write on the bottom. Uh, fourth floor. Fourth floor. So IB 401. This is time. Actually, it's 2.5 hours. So let me just write this. 2.5 hour duration. So please come to the class. Okay. Okay, I think IB 401 is, I think, quite spacious, quite huge. So yeah, I hope enough students can sit down on the class. Okay. So I think that's it for today. If there is no question from you, and I will also attach the other class discussions from yesterday class to you, and also I will share the notes. Okay. If there's no questions, then let me end the recording, and I will share the recording also later.